Hello everyone. Um, the topic I'm going to present today is persistent 3D stabilization for aerial imagery. I'm Burjun Chen from University of Southern California, and this is a joint work with my advisor Gerard Milioni. So this is the wide area motion imagery we have as input. So this imagery is captured by a camera mounted on a UAV. As you can see, everything in the scene is moving, and therefore it is very difficult to directly apply this imagery on applications such as moving object detection, tracking, or activity recognition. And therefore, most existing methods use 2D stabilization to compensate camera motion. However, 2D stabilization cannot handle the 3D structure under the scene. As you can see in the middle column, if we are interested in the green points, they are actually a drift here from the green point to the red line, which shows the alignment. Therefore, our goal is to create a video as if the scene were captured by a static camera, as shown in the right column. And it is not only a better visualization tool, but also a more reliable input for higher level applications. This is our pipeline. So given an aerial imagery, we will use the first frame as a reference frame. And we want to find the accurate dense mapping that accounts for camera motion only between the first frame, which is the reference frame, and the current frame. This is done by two steps. First, we compensate the outlier flow from moving objects. And then we use a two-pass mapping integration strategy to reduce mapping errors. Another thing we need to handle is the occlusion part, because there are some pixels at the reference frame that cannot be seen at the current frame. To do this, we first identify these occlusion regions using a semi-global matching method. And then we try to fill in this occlusion region using a dynamic background model. And here we show the example result. And now I want to show some videos for our stabilization method. And in comparison with other two methods, the right top one shows a 2D stabilization method. You can see that the buildings are tilting in this method. And the left bottom one shows a state-of-the-art 3D stabilization method. However, they cannot handle the occlusion region properly, so there will be some stripes occurs around the buildings. While our method handles these situations correctly. This is another result on a different data set. I don't know if you can see the vehicle is still moving, while other things are static. And then we further apply the stabilized video to a moving object detection method, which basically based on the background subtraction. As you can see, use 2D stabilization only will generate a lot of false alarms around the 3D structures. Using a post-processing by a gradient subtraction will reduce the false alarms from weak parallax. But the false alarms from strong parallax, such as high buildings, are still remains. The 3D stabilization method in 2014 will generate additional false alarms from the occlusion regions, which they cannot handle it properly. While our result identify the detections correctly while not introducing more false alarms inside.